Boop. You guys heard that. All right, so now she's on record. We're recording the overhead cam. So as I mentioned, we're going to take up this worksheet that I had handed out. All right. So let me see if I can zoom that one in. So some days it seems like she gives me a bit of a fuzzy picture, but I'll write this one out as well. So this page kind of was set up the way that we were actually working through some of our stuff. That might be a little better. All right. So essentially when I was doing this one on my own, I actually rewrote this just so it was more clear to me. And I actually put them into more of a on top of each other sort of orientation. I just thought this one was a little easier to kind of read if I looked at it like that. Then from here, remember when we add and subtract, we need to make sure we have apples to apples and so on. Right now we've got 3 different numbers. But is there a number that relates to all 3 of these?
4.
4, or so think about the highest one.
16.
Yeah. So all of these numbers can relate to 16. So I'm going to leave the 16 the way it is, but I'm going to change the 8 and the 4, right? So in order to make the 8 a 16, I have to multiply that by 2. So I have to do the thing.
Is that a technique you use, or in terms of just trying to figure out the highest out of the bottom denominators? Or?
Yeah, I usually go with, whichever happens to... Hold on one sec. Can you guys give me just 1 second?
Yeah.
Sorry. Yeah, someone's at my front door. I don't know why. So sorry, Poku, yeah. When it comes to something like this, yeah, I'm usually trying to find the number, the highest one, right? Because I don't want to reduce the 16 down to anything. So what's the biggest number that all 3 can relate to? And it's the 16. Does that make sense?
Yeah, that makes perfect sense.
Okay, awesome. Thanks, man. Right, so same thing when I get over to the 3/4. I got to turn that into 16. So I'm going to multiply that by 4. Okay. Sorry, I thought I heard someone coming in. Oh, Gary. What the hell, Gary? There we go. All right, so multiplying them to get the 16. So I'm just going to rewrite this out now that I've got these in here. So 8 times 2 would be the 16. 1 times 2 is 2. So 2 over 16 plus the 5/16 stays the same. Plus 3 times 4 is 12 over 16. Now we have all apples, and we just add these ones up together, right? So 12 plus the 5 is 17, plus the 2 is 19, right? So 19 over 16. But remember, we have that improper fraction again, right? Remember what we do with those?
Change to a small number.
Not necessarily change to a small number.
How much times the 16 goes into the 19?
Exactly.
Yeah.
Hold on one sec. Hold on a sec, guys. Sorry about that. Yeah, so you're right. So I think that was Poku that said that, right? So how many times does 16 go into 19? It goes in once.
1.
Right? And then we have remainder of how many? Right? 19.
3.
Yeah, exactly. So 19 minus 16 leaves us with 3, and we continue to use that denominator. Okay, so that is the final answer for that one. Did anybody get something different?
No, I got to the answer.
Okay.
Don't ask me how, but I screwed up the formula.
But you got to that 1 3/16?
Yes.
Hey, that's okay. I mean, it's nice to know the path that we got there, but there's different ways of doing this stuff. Just as we kind of mentioned once about the new math that some of the young ones are using. All right. So how about the number 2 here? We'll do that one as well. And again, I just like writing it out in a way that makes things a little more clear for me. So I'm going to put the whole number and then the fraction. Plus this one just happens to be a fraction, no whole number.
And
And
I have a question for you.
yeah.
Should your screen be showing your hand right now?
Yes.
Because it's just showing you, for me anyways. I don't know about anyone else.
How about
just and then the numbers.
you see who doesn't see the screen with my hand? Is it just Gary? Here,
Odd man out.
you're the odd man out. All right, let me try. Let me do it one more time, Gary. I'm going to stop sharing and try it one more time. Something could have just happened.
Sure. I might have been out at that time, so.
Oh, yeah. Okay, that makes sense. Yeah, you popped out for a quick sec. How about now?
There we go.
Good.
Thank you.
No worries. All right, so I kind of, like I said, I just wrote it out in a way that makes it easier for me to see. But again, we've got 3 different denominators. And here again, Poku is where I'm going to see what's the highest one, which is the 32. Can it relate to the 16 and the 8?
Yes.
Yes, it can, right? So 32 is what we're going to use. What do I have to do to get 16 to 32?
Multiply by 2.
Yep. Right, so whatever I did to the bottom one, I do to the top. How about the 8? I have to multiply it by?
4.
Yep, so same thing on that one there. And again, just for clarification, I'm going to rewrite this again. So now we'll keep that 9 and 5 30-seconds. Whoops. Now this is going to be 22 over 32. And this one's going to be 4 and 12 30-seconds. So again, now we've got all our apples. So now remember, the whole numbers get treated together, right? So 9 plus 4 is 13. So those are the wholes. Now we take care of these ones, right? And we're going to end up using that denominator of 30-seconds, right? And 22 plus 12 is 34 plus 5 is
39.
yes, 39. But again, that's that one of those improper fractions again, right? So I'm going to isolate that for a second, and we're just going to worry about the 39 over 32. What do we do with those impropers? How many times can 32 go into 39?
1.
Only once, right? So 39 minus 32 leaves us with how many remainders?
7.
7, and we're going to use that denominator, right? So that's what that fraction equals. But we still got to deal with this whole number. We bring that over, right?
14.
Exactly. So it's going to end up being 14 and 7 30-seconds. Oops. And that's the final answer.
So let's say we have, you see how you have the answer right now?
Yeah.
7 could go to 32, no?
Can it?
No.
It will have a remainder.
Exactly.
7 times 5 is 30, so would I have to simplify it again or no?
No. So, yeah. Yeah, so when it comes to the fractions, the only time, I know what you were thinking, you're probably thinking...
Sorry. I said, Yeah, I made a mistake. I said 7 times 5 is 30, but it's 7 times 5 is 35, no?
Yes.
Yeah, sorry. My mistake.
Yeah. So the one that we were dealing with here, Poku, and I wonder if that's what you were thinking about. The only reason we did the 32 into 39 is because of the fact that it's that improper. It's more than a whole.
Oh, okay. Yeah, you're right.
Right? So it's like
when I see a lot of numbers, it's like at the grocery store. It's just too much things.
I hear you. That's why I have to do a lot of like writing things out for my own clarification. Like honestly, this side by side, I can't look at it like that. I have to do this. It's better for my brain.
Exactly.
Yeah.
Exactly. I like to break it down all the way down, right?
Yes. Yeah, exactly. Right? Whatever ends up working. I still do a lot of stuff in a way that seems long and drawn out, right? Even on Tuesday night, Renee, when we were talking about, when you mentioned the factoring out, I had completely forgotten about that stuff. So when you said that, I was absolutely like blown away, just because it makes life easier, that one. Right? All right, let's visit the subtraction. All right, so number 3 here. Yeah, the camera's looking a little odd today. So again, I like to rewrite. And that's just how I deal with it. 1 and 5 over 16 minus 3 over 8. All right, now we need to get them into apples and apples, right? So,
are you going to multiply by 2?
Yes, yeah, because the 8 can go into the 16 evenly. So I'm going to make that into a 16th. So multiply that by 2, which means I got to multiply that one by 2. And again, I'm just going to...
Is there any chance that you would need to... Would there ever be a question where you need to, like, have you come across a question where you need to change it to an improper fraction in order to do that?
This is a reminder.
Yeah, hold on one sec.
Feed the
Alexa,
animals.
stop. Holy crap. Alexa, stop. Jeez Louise. She gets louder and louder. Turning it into the improper fraction, Poku, that happens when we're doing multiplying and dividing. Yeah, that's when we have to get rid of those holes, the mix, and turn it into that improper. And actually, yeah, no worries, honey. We'll actually get to that when we get down to 5 and 6.
Sorry.
No, don't be sorry. Everything's good. Right?
Oh, no, I never said sorry. I said all right.
Oh, okay. All right, good. Okay, so when we do the multiplying, right, to change that all into the same thing, again, I'm just going to, for sake of clarification, rewrite it now that we're going to change it. So 3 times 2 is 6. 8 times 2 is 16. Now we have our apples to apples, right? Hold on one sec. Ooh. Yes, sorry, Poku. I'm looking at my notes. This one might be easier to change into the improper first. 1 times 16, 16.
Oh, you still can try change it into improper than a second step. It's fine too.
So we can solve it this way, or we can do what you did, Poku, or how you were suggesting. Right? You can actually change this into the improper. So 1 times 16 is 16, plus 5 is 21. All right, and we can actually do this. Let's see what happens there. There we go. All right, so then 21 minus 6, what do you get?
15 over 16.
15 over 16.
That's
right?
it.
And that's it. It's basically almost a whole. I did, Poku, I did. Because, yes, buddy, you were, yeah, that seemed to be the easiest way.
So can you go through that again? Can you go through that change again?
Sure.
So you did the 1 times 16 is 16, and then you added the top, right?
Yes, you got it.
Add the 5.
Yep.
21 over 16.
Yeah. So anytime you do those impropers, yep, the whole times the denominator plus the numerator, 21 over 16. All right, and then that's our answer. So essentially what we're saying is that, let's call it 1 inch and 5/16 minus 3/8. We're left with 15/16. Essentially almost a whole inch.
Yeah, that's true.
Mm-hmm. Yeah, and again, this is something that you could absolutely look on a tape measure and see it, right? We could actually even look at a tape measure. Ooh, do I have one handy? I might have a picture of one.
I never thought about using the tape, but now I'm using a tape a lot more, and then now I can relate to it.
Yes, right? So that one there, say 1 and 5/16. So 1 inch. Oh, this one doesn't go down to 16ths entirely. It's just eighths. But it is something readable. So this is in eighths. 16ths would be the little ones all in between. Right? But yeah, that's exactly it. Renee, it was you that was saying that once you start looking at the tape measure, you can start relating this, eh?
Yeah.
Mm-hmm. And I'm going to try and get into some of that today, possibly. All right, let's look at this one here, number 4. So again, I like to write it out so I can see it better. 1 and 3/16 minus 7 over 8. All right, so going by Poku steering us in the proper direction, I'm going to turn that into an improper. No, be confident, buddy. You caught that one. So we'll change it into an improper. So 1 times 16 is 16, plus 3 is 19. So 19, I'm going to rewrite that. Oops.
19 over 16.
Yes. 19 over 16. 8 relates to 16, but in order to change it to that, we multiply it by 2, which means we do the same thing to the 7, right? So we'll put that 16 down there. 7 times 2 is 14, right? And we know we're going to end up with 16 at the bottom. 19 minus 14, and we're left with 5/16. And again, that's as low as that one will go. And again, it is measurable on a tape measure, 5/16, right? It would actually be down, now the inch part's hard to see there, but if I split these guys all in half, 5/16 is actually right here. Oops, you guys can't see that. So I'm pretending that's the 0, right? So not quite a whole. And 5/16 is just over the 1/4 inch mark. Right? 1, 2, 3, 4, 5. Oh, sorry. Yeah, the 1/4 inch mark, right? 1, 2, 3, 4, 5. We're just past the 8th mark. Right? 16ths, 8ths, halves, quarters, 32nds, all can be read on a tape measure. Did you guys get those ones okay?
Yes.
Recording. Good. All right. So here's the times table one, or the multiply. Again, I'm going to write it out to clarify. 6 3/4 times 3 and 1/8. Right, we're going to turn those into mixed fractions. Okay, so 6 times 4, what do you get?
24.
Yeah.
24.
Yeah, 24 plus 3 is 27. Right, so 27 over 4.
Over 8.
So that's just a second
Nope.
option, right?
Yeah, just over 4, yeah.
This way.
Right.
Pardon me, Poku?
That's just a second option. The way that you're doing it before is also another way we can use too, right?
What other way, love, are you talking about?
So you see how in the adding and subtracting we're changing. We had an option of when I suggested we should change the mixed number to improper.
Yeah.
In the multiplying and division, you have to do that.
I don't want to say you have to, because maybe there's some weird new way or something that I don't know. This is the best way that I know, and it's the way that I was taught.
Okay, no problem.
Yeah, yeah. But again, Poku, there's 100 different ways to skin a cat, as they say, right?
Yeah, for real.
And there are different ways of doing math. This, like I said, this is just how I was shown, and oddly enough, it's in all of my instructor stuff here too.
No, you make it easier.
Oh, thank you, man. Thanks. I'm trying, right? Because I think I mentioned to you guys, math was never my thing growing up, right? Even now, there's days I still get a little nervous when I have to break it down for someone else. Because
All eyes on you.
that's exactly it, right? It's a little nerve-wracking when you've got. So yeah, so I changed. Yeah, so going for that 3 one, right? So 3 times 8, what do you get?
24.
Plus the 1 is the 25, right? Yeah, 25 over 8, because we just use the existing denominator. So now remember, with multiplying, we don't have to change any of these things. We just go right across, right? So 27 times 25. You can either long multiply or pull out your calculator real quick. But I got 675 over the 32. Right, that's a huge number. So again, here's that improper fraction. Right, so this is the moment that it's kind of like doing a division. Right, I think we kind of touched on that real quick on Tuesday, Renee, when you were sort of having a hard time with that big one. So in order to break this down and find that mixed number, how many times does 32 go into 675? So
it's 21 times.
Yeah, 21 with some remainder, right?
Yeah, with 3 over 32.
All right, so 21 times, right? Because then, 21 whole times. So we actually multiply 21 and 32 together. Times 32 equals 672. And I take 672 away from that 675. 5 minus 672. And yep, you get that 3 over 32. Did anybody get lost there?
No, actually, I got that right.
Nice. Nice. That's good. It's a good feeling. Especially when you're not 100% sure. And that was something that happened to me a lot too, as math was starting to kind of click in my head once I got into the trades. There would be a few moments that if an answer came too quickly to me, I was like, no, something's wrong. That seemed too easy. But it's like, no, you're learning. That's why it came easy. All right, let's look at this one here, and then we'll get into those tricky word problems. So again, and especially because I know these aren't showing up very well on the camera, so another reason why writing it out helps. 1 over 16. This one's a divide, right? Divided by 4. So I'm going to turn this into an improper fraction again, right? So 3 times 16. What do you get? 48. Plus 1 is 49. So 49 over 16 divided by 4, but we have to make this a fraction as well. And remember what we said, it's as simple as just throwing a 1 under it. So divided by 4 over 1. Now remember, you can do the cross multiplication if you remember which one goes up top. I told you I can never remember, so I just do the flip, right? The reverse. This one stays the same. It's this one that's going to change as well as this. So I'm going to...
You can only do that to the second fraction, right?
Correct, yeah. The first one stays the way it is. So 49 over 16, that stays the way it is. I'm flipping this bad boy right here. So I'm also going to flip the what we're doing here. The opposite of divide is to multiply. And now it's 1 over 4. Are we all together so far? I hope so. And then 1 times 49, because remember we treat them all different. That's a set and that's a set. Unless we have the factor outs, which we don't just yet. So 49 times 1, 49 over 16 times 4, and we get 64. And I don't think anything can go into both of those evenly to shrink it down. So I think that's the lowest, right? Unless there's a number that will go into both of these evenly, that's our lowest common number. How'd you guys do with that?
No, wrong.
Okay, so just so you see the top ones one more time. Okay. And there we go. I'm going to pause for a quick sec.
No, I get that, but if you're looking at a 64th on a tape measure and a 32nd, I mean it's so small that you're not going to see that half 32nd.
Yeah, I'll be honest with you, Gary. When it comes to something like this type of a fraction, you're not wrong. A 64th, you most likely won't find it on a tape measure because it is so tiny, right?
That's right.
Yeah.
This would be something that if I needed to use this measurement properly, this is where I would be turning this bad boy into a decimal and then into millimeters, because it's a more precise measurement, right? But definitely, you know what? I'm actually going to circle this one, and once we get into the converting, I'm going to utilize that one with conversion. Imperial.
If it's construction math, you want to make it relatable to what it is that you're trying to see on a tape.
Oh, I know, hun. I've taught this course a few times. I just have to make sure I'm going in some steps as well, right? To make sure that everybody's.
It's not for you, Carrie. It's for the ones that aren't familiar with the tape.
Yeah. Yeah. No, that's not a bad point to make, Gary. Right? Because again, some tapes will have both the imperial and the metric, right? That might be a little easier to see it. But this is where I'm saying, yeah, like we could convert it. Yeah, and Gary's not wrong. It is a way that we can then properly attain that precise measurement. But we'll definitely get there. And I'm going to use that one for our conversion then. Never figure out what information they were asking. So the first one here is asking which is thicker, 3/16 or 13/64. And the way we can do that is, again, I'm going to just write these so I can see them again. Nice and easy, right? Let's say versus 13/64. So 64 is the biggest number here, and I want to see if I can get 16 to turn into a 64th, and I can quite easily, can't I? I believe it's times 4. Am I right on that one? Yeah. All right. So to make 16 a 64th, pardon me? Oh.
So 316 is 4 times larger than 1364.
All right, so hang on a sec. All right, I'm changing this one so it's apples and apples. All right, so 3/16 now turns into 12 64ths. So which is bigger? 13/64 by a fraction.
That's right. Yeah.
Does that make sense?
Yes.
It's like if we were going to set this up as an adding or subtracting. Instead, we're just trying to find what that difference is. Okay. So not too bad. You guys didn't seem like you had a hard time with that one. Now we get to this number 8 here. It says 8 lengths of threaded rod, each are 4 3/8 inches long. They have to be cut from a piece of threaded rod. There is a 3/32 waste for each cut. What is the minimum length of rod you will need? All right, so this one, the way to me that it's set up, there's 8 lengths of rod. Okay, so the 8 has to be in there somewhere. I'm going to use the 8. I'm going to use the 4 3/8. Have to be cut from a piece of threaded rod. The whole rod, or there's waste. Okay, that's going to be the waste. And I need 8 pieces. So when you're cutting one rod, think about when you're cutting something. Right, I have a whole rod, but I'm only going to, do you guys understand that I'm only going to be making 7 cuts? 1, 2, 3, 4, 5, 6, 7 cuts. Is that it there? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So I made 7 cuts. So when they're talking about waste, they're talking about because of the blade, the kerf of the blade. So when you're cutting lumber or cutting anything, you always have to keep in mind that there's going to be waste because of the size of the blade. And that's what they're talking about here, right? The blade kerf or cut is about 3/32, right? And I'm cutting 7 times. So keep that 7 in mind. Are we together so far?
Yeah. All
right. So here's what I'm going to do. This is a little bit of bed math as well. So I'm going to take this 4 3/8. 4 3/8, my bad. Right? Well, I don't need the inches in there. I just need the numbers. I need 8 of these pieces. So I'm going to times that by 8. But I'm also going to put that in a set of brackets because it's its own thing. Because eventually I have to, what is the minimum length of rod you need? I'll have to find out how big of a rod that I need to cut all this from. And inside, I want that waste, the waste number. And again, I'm making 7 cuts. Right? We're trying to find the minimum length of rod, so I don't have a whole lot of other waste. Does this make sense at all so far?
Yes.
Okay, good, good. So again, remember we have a couple of a mixed fraction here. So I want to turn that into an improper. So 4 times 8, again, I believe is the 32, I think, yeah, right? 32 plus 3. Yes, so this turns into 35 over 8 times, remember, we just want to turn that whole number into a fraction. 8 over 1. Keep it inside your little bracket. Right. Inside this one, 3 over 32 times 7 over 1. Remember, we just need to turn that into a fraction. Okay. So now we do each one of these brackets separate. So 35 times 8. I've got 280 over 8, right? And then 3 times 7 is 21 over 32. Okay? But I have to turn these into apples and apples. Does that make sense?
Yep.
Okay. So in order to, oh Jesus. Trying to think if there was another way to do that one without that number getting so damn big. If I go, okay. Oh, I can. Did anybody else notice this? 8
Yeah,
can.
it's divisible by 2.
2, yeah.
Oh, this one I can bring right down to, I believe, a whole number. 35. Does that make sense to anyone?
No.
No? Shit.
Yeah, it makes sense.
280.
Yeah, because 8 goes into 280
Yeah,
35 times.
yeah.
All right, I could do the whole rigmarole, but it goes in 35 whole times.
Yeah.
Right? So that basically is like I got rid of that. And that would be our answer. Okay, okay. Yeah, because that was an improper fraction, guys.
Yeah, it is improper.
Mm-hmm. So we just...
What happened to the premise of making the bottom numbers the same?
We could have done that. If this
you
had...
arrive at the same answer eventually, but
Yep.
this is the shortcut.
Exactly. So because that was... And let me get rid of that little cross out. Because it was an improper fraction, if this had have been a number where there was a remainder, then we would have had to find, then we would have had to make sure the apples were all the same. I wish I had another one I could kind of quickly bring up as an example. Where's one of our other ones? Okay, so take this big one here, right? It was an improper fraction, nice big number over a smaller number, right? But this one didn't go in completely evenly,
Right.
right? it went in 21 times, but there was a remainder. Right?
Yeah.
When we did this one, we just got lucky that there was no remainders left over.
Mm-hmm.
Did that make sense?
Yeah.
Yes.
Right? Because again, when we've got the impropers, this becomes a division question. Essentially, it ends up looking like this. Right? But again, remember, we would have ended up with this and then a remainder of a bunch of other decimals under here. This one, when we take this, and do you mind if I throw it over here for a quick sec?
Yeah, go ahead.
Right? So essentially that one's going to be this. Right? And it is even. Right?
Yeah.
If we did that long division wise, we can say 28 divided by 8. Right?
Or multiply by 35, you'll get 280.
Yep, exactly. Right? Because it'll run through the whole long division to get us with that 35. Right? Let me do that just so you guys can see. 8. You get your 3 wholes, right? And 3 times 8 is your 24. 8 minus 4, we left with 4. Bring down that 0. 8 goes into 4. 5 even times. 0 remainders. There's our whole. Drop it down. Did that make more sense?
Yes.
Yeah, but had I had that remainder, then yes, I would have had to turn that remainder into apples and apples. But we got lucky on this one.
Mm-hmm.
Cool. Alrighty. Let's go down to this bad boy. So the thickness of a dado blade. So a dado blade, they use it for, say, making grooves, groove cuts in lumber, things like that, right? Sheet goods. Yeah, you kind of get the idea. I swear I'm an artist. I don't just play one on TV this time. Right? So that's a dado blade. So the thickness of a dado blade setup has to be increased by installing a 7/1000th of an inch shim. So extremely tiny. The original dado blade set was 7/8. What's the new thickness of the blade? This is going...
Subtract.
Pardon me?
You subtract?
It's actually going to be an addition, right? Because the first thickness, the first thickness of the blade was this, and I'm putting in a shim of this much. So what's the new thickness of that blade? So,
Okay.
yeah. So I'm going to write that out. Again, I'm going to put them on top of each other first for clarification. So I'm the blade plus that shim of some crazy number here, right? And 8 can go into 1,000 evenly, can it not?
Yes.
Right. And what are we going to multiply it by?
By 125.
Exactly. Sounds big, right? So 8 multiplied by 125, and then I have to do the same thing to the 7 as well, right? So let's rewrite that as, I believe it's going to be 875 over 1,000.
875, yeah.
Yeah. Plus, and we keep the shim the same because that's what we were sort of following because it was the larger number. Okay. So then 875 plus 7 gives us 882 over 1,000. Right? But I think that can be reduced because it is 2 even numbers.
Yeah.
Right? And I'm just going to go with cutting it in half. Let's see what happens from there. So 2. I just cut it in half by so divide it by 2 and 500. But I think that's as low as that one would go. But that, kind of like, again, what Gary was saying, this is not something you will read on a tape measure, right? Because this is fraction of inches, right? And eventually we would get into turning this into a decimal, right? Something that could be read. So that's a fraction of an inch. Ooh, I'd have to double check that one. Right, but we'll get into that converting. But yeah, I would change that into a decimal inch just for shits and giggles. Turning that into a decimal inch would be a matter of this divided by this, right? And you get something like 0.05 something or rather. But we'll get into that lesson shortly. But this is as low as that one goes. Good so far? Sort of?
Yeah.
All
Good
right.
so far.
Okay. I'm going to pause. Yes, and a lot of people do. Because sometimes, and I'll have to double check as we go along, there might be what they call red herrings, right? Something that's kind of in there that it's not really pertinent information. It's kind of just going to screw you up. Right, so it's trying to figure out what it's asking you to do.
So does the red seal have a word problem too?
Oh, yes.
Oh my goodness.
Yes, it does.
That's what I'm scared of.
Since I'm doing these overhead ones and recording it, as long as you guys hold on to those links, and if you ever lose them, let me know, and you just keep going back to it. That's kind of why I liked having this.
Yeah.
And kind of like you were saying, Poku, I'm going to try and give myself some time and pre-record. That way I can kind of relax and I don't have the pressure of maybe screwing you guys up on something. Because there were 1 or 2 times that I know, shoot, my brain's not thinking right now. Right?
Yeah, that's a good idea.
Right? Oops, sorry. I was paused. So when they're talking about scaling, it's so that they can get a large drawing onto a smaller set of blueprints, right? And if you've ever seen a set of blueprints, if you look down in the corner, they'll usually tell you what scale it's in, right? So that you can understand. And this one's saying that for every foot, it actually measures out to 1.5 inches. Right, so, or sorry, I should say every 1.5 inches. And if I was to actually say, look at, so our graph maybe might help us out here.
It's equivalent to 1 foot.
Exactly. So for every 1.5 inches, it is equivalent to 1 foot. So if we were to say, it's probably not the graph. Easy there. So basically, if you were to see something on the page, you know that, okay, well, I have to, every one of these 1.5 inches actually equals a foot out in the when I'm trying to build it. I'm probably butchering that. So essentially, so if we take the first one here, that one's fairly simple in the sense of I've got 25 feet. Well, it's just a multiplication one, right? So it's essentially 25 times 1.5. Oh, I almost went into my decimals and did 1.5. We can do that, but we're dealing with our fractions for now. Okay. So remember, we would have to put a 1 under this. Change this into an improper right? So essentially this one is written out as 25 over 1 times 2 plus 1 is 3 over 2, right? And what do we get? 75 over 2. Right, again, remember there's that improper. So how many times did 2 go into 75?
37.5.
That's the final answer. Yep. But yep, 2 goes into 75. What is it? Yeah, 37 times. And then, so 37 whole times. It's actually 37.5, right, will be the final answer.
37.5.
Oh, yes. Well, 37.5, 37.5, yes. All right. But if I wanted to, I could do this long. 37 is 2 equals 74, right? Because remember, and this is where we'll do the factor. I'm just doing it out long for the sake of following through, right? Because 37 times 2 is 74, right? So 75 minus that 74 gives us 1 over the 2.
Over 2. Yeah.
Yep. Good. You guys got, some of you got there nice and fast. I like that. All right, so do you understand what that whole 1.5 to each foot?
Yep.
So basically, you're going to go along and multiply all of these, each one of these, by 1.5. Okay.
Hey, sorry, it just kicked me out.
Oh. Did you get back in? Someone let you in?
Yeah, I'm good. Thank you.
Okay.
I can't see the screen though.
Oh, yeah, that's because you were kicked out. Hold on one sec. Let me try and refresh here.
Thank you so much.
No worries. And again, a beauty of having the camera. Whatever you missed, you can pick it up. You're back in there, Poku? You got it?
Yeah, I'm back in.
Okay, and you can see the screen?
Yeah, I can.
Beautiful. All right. So, yeah, let's go with that, the second one, right? The kitchen. So we did the living room. That's the final for the living room. The kitchen is going to be 16 1/2, right, times the 1 1/2. But again, we're going to change those into mixed fractions, right? So 16 times 2 is 32, plus the 1. Is it 33 over 2? Times 1 times 2 plus the 1. We've got our 3 over 2 again. And then we just multiply those out. So I believe it's 99 over 4. Right? We can definitely, so I'm going to go 99 divided by 4. 4 goes into, yeah.
24 and 3/4.
Yep. As it goes in 24 whole times, right? Now, I knew it was the 3/4 by the decimal, but if I follow through the long way, again, just for clarification, 24 times 4 equals 96. 99 minus the 96, and we get our 3 over 4. Right? Okay. So again, let's do our bedroom, or at least bedroom number 1, bedroom number 2. So bedroom number 1 is 18 feet times our 1.5. Right? We'll get there a little quicker this time. 18 over 1, because remember we just want to make that a fraction. 1.5, stick with that 3/2. Right, and we get 18 times 3 is our 54 over 2. How many times does 54 go in, or sorry, how many times does 2 go into 54?
27.
27. 27 even. Right? So that's it for that one. Now we're going with bedroom number 2. So this one's going to be 15 3/4. So Jen, you were kind of asking some stuff too. This is also different ways that you can you'd be using this for, say, the real estate stuff, right? Wanting to know how many square footage in each room and different things like that. This is some of that stuff here. Well, not the square footage, not yet, but you get where some of this can come in handy as well. Right? Figuring out stuff like what do I need to, how much material do I need to buy for this, that, and the other, right? Sorry, I got off track there. Times are 1 1/2. Again, turn these into our impropers, right? So 15, this one's going to be 63 over 4 times 3/2, right? We're going to multiply 63 times 3 to get 189 over 8. Again, 189 divided by 8. I get 23 wholes, right? And again, 23 times 8 is 184. Whoops, 184. And that's what we got, our 5, right? 5. We use that denominator over 8. And that's as low as that one goes. Okay. Cool. So that would be your scale measurements in inches. So yeah, each one of these are inches. Right? So basically what it's saying that, yeah, on our scale, we're going to actually be using 37.5 inches. Do you guys know what the scales look like? Have you ever seen those triangular, like, rulers?
Oh, those are architect.
Yes.
Oh,
The architect scales.
Scale.
Yeah, you got it.
Or engineering scale.
Yep.
Whatever.
Yeah. You got it. That's them. Whoops. Those are scales.
Yeah, I got confused by a bit in that ruler.
Yeah, it takes a minute or two to learn it, but it is quite handy.
Yeah.
Right? I use this a lot. Funny enough, my dad's not good with the word problems, but he knows how to use the scales really well. He ended up doing out his whole back deck, this big raised back deck, and drew out all the plans to scale, right? So meaning what he saw on the page, once you blew it up, it transferred to look exactly like what the picture looked that he drew.
Oh, that works.
Yep. Yeah. It is quite wild. It's really neat. And if we've got some time as we're going through over the next couple weeks, maybe I'll try and introduce that a little bit.
Yeah, that would be great. I think that will be good for our second term.
Mm-hmm. Yes. Yeah, because you definitely will use it a bit more in second term.
Yeah.
Yeah. They did touch on it in basic, I believe.
Yeah, a little bit.
Mm-hmm. All right, let's take this one. So if the unit run of each step is 8 3/8, so when they say a unit run, so each one of these steps that you put your feet on is...
That's how wide it is.
Exactly, that's how wide it is. Right? And it says if each one of these steps, each unit is 8 3/8 inches, what is the total run of the stairs? So you literally actually have to count how many there are there.
Oh, okay.
And within here, I believe there was 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 steps. Right? You see that there? So 11 steps. Right? Or 11 treads, they may call it.
Oh, the top ones don't count, right?
No, especially since you see where they've cut off the lines, they've given you that barrier.
Ah, okay.
Yeah. So when it comes to stairs, the piece that you step on, right, the flat piece, that's called a tread or a run, and the vertical is called a rise.
Rise, yeah, makes sense.
Right? So in this case, it's just going to be a matter of this number and this number. So essentially, this one is asking for this action. Right? So again, you would convert those, right, or turn them into an improper fraction. This time it's going to be 67 over 8 times 11 over 1. Woo, and we're left with a big number here. 737 over 8. And again, this is a division right here. Right, again, if that helps you to see it more like this. Right?
9.
So yeah, 737, whoops, 37 divided by 8. We get 92 wholes, right? But there is a remainder. So 92 times 8 is 736, right? And we're left with a remainder of 1 over 8.
8.
Right? So the total run, meaning if we were actually to take away all these risers and flatten those stairs out, that total run, or all of these together, would equal 92 inches, 92 and an eighth inches. Right? And that we could actually turn into feet as well, but we'll do that another time. I'm going to try and get you to the converting feet and inches back and forth, and possibly decimals into feet and inches as well. Hopefully tonight.
I require a lot of practice.
Yes, yes. That's why I was hoping I can get to that one tonight, so that you have all weekend essentially, you know, a good handful of days to play around with that one.
Yeah.
And again, if we don't get to it, here's again where I'll take that advice from Poku. I'll put it into a video that you guys would be able to access over the weekend if we don't get to it.
Yeah.
Okay? So let's turn the page and see. Others are kind of going, oh, actually, yeah, this kind of helps. All right. Now, I know you can't see these on screen for sure, because I could barely see them in person. But let's see what it's asking here. So find the missing dimension in this figure. If the total diameter of the circle is 2 3/4. So diameters mean from one edge to one edge. If it said radius, it would mean from the center out to one of the sides, or half. So in here, and I'll try and write it out so you guys can see it a bit more. This section right here actually says 5/8. This little section here says 3/4, and it's this section here that we don't know. Okay, so what we're going to do here is we're actually going to add these two together because these are the two knowns, and it's actually the whole radius, right? And once we add these two together, yeah, then we can kind of break it on down. Let's see. So let me write this out over here. Am I recording? Oh, no, we're recording. Okay. So 5/8 plus 3/4. Right, again, we're adding, so we need to apples and apples. You guys are getting this though now? Turning apples to apples?
Yeah.
Good, good. Okay. So essentially 5/8 plus 6/8. And we are left with 11/8. This is an improper. Eight goes into 11 once, right? 11 minus 8 is our 3. 3/8.
Yeah. 3/8, correct.
Yeah. So remember I said diameter, or find the missing. So you guys can see these two make up half, or the radius. Right? So the total diameter of the circle is 2 3/4. Well, I just basically, yeah, exactly. Once I found these totals, I would just subtract this from this, but you're going to be left with this.
Yeah.
Right? Because, like I said, a radius is half the diameter. Did anybody get lost? Are we feeling good? Good. Because if you...
Go through the last step.
Sorry?
You just walk through the last step.
Yep. Are you talking about this 11/8?
No, the 2 3/4 minus the 1 3/8. Like go through the complete.
Oh, you want me to do... Yeah, no worries. Just to check it out, right? Okay, so let's do that. So let's take that 2 3/4 minus 1 3/8. Right? Now we can treat these guys separate. Right? 2 minus 1, we're left with the 1. Then treat these fractions. So apples to apples, I'm just dropping this down for a quick sec to make it more easy to see. Six minus 3, 3. And we just take that little bit and bring it back up to here, right? Because that's the fraction we were trying to figure out. All right? Did that make sense? Oops, shit, sorry, I didn't realize it was down below.
Yep.
Because again, remember what I said? That was half of our circle, which is the radius. 2 radiuses make a diameter. How do we feel about that one? We could even do something as far as taking this number and multiplying it by 2. We'd end up with this 2 3/4 again.
Yeah, that's right.
Mm-hmm. Oh, math. You're so much fun. Holy crap, there's a whole other page here. All right, we'll take a look at this one down here. Scaffold screw jacks.
Ooh, this one important.
Yeah, I kind of thought this one was...
Scaffolding, we'll have to calculate this. I was totally lost.
Yes. So a scaffold screw jack advances 1 inch for every 4 1/3 revolution. So every time I turn the foot 4 1/3, it equals 1 inches. So does that make sense? I'm trying to find something that might turn here, like some kind of a gear. All right. So every time, I know it's not a screw, but every time that this would say turn, this is my point, right? 1, 2, 3, 4, and a little bit, right? If this was a screw and it's coming out, for every 4 and a bit times it turns, it's actually getting 1 inch bigger. Does that make sense?
Yes.
Okay, cool. Right? So every time it turns 4 1/3, it advances or gets bigger by 1 inch. So we want to find out how many revolutions will it take to advance 3 inches, right? In order to reach, what's that?
So multiply by 3?
Exactly. Exactly. You got it. Right? So we're going to say 3 inches, that's an information we want, times the amount of revolutions it takes to go 1 inch, which is 4 1/3. All right. So again, we're going to change all this stuff. And I know some of you might be like, okay, I get this step, but I just want to kind of continue on to make everything nice and clear.
We go to 13.
Yes, the final answer will be 13 revolutions or 13 turns. 4 times 3 is 12 plus 1 is 13 over 3.
Yeah, you cancel it out.
Yes!
13.
Exactly. There it is, Renee. The cancel. So that factor out.
Like the cancel. I always look for a cancel.
I love it. Yeah, you don't know, honestly, how excited I got about that. After we were done that night, I was like, oh my God, to my husband, do you remember this? Because I didn't remember it until someone brought it up. Factoring out, yeah, because this numerator and this denominator are the same, and it only happens in the multiplication. We actually can get rid of these. Because like Renee says, it just makes this a little faster that we end up here. And remember, 13 over 1 or any number over 1 is essentially the whole. So revs or turns. Oh, who's calling now? Sorry guys, hold on one sec. Hello? Yeah, so did that one make sense to everyone?
Yes.
Right? So meaning if I was to, like if this was our screw again, and I was turning it, if I turn it 13 times, this will have come out or gotten bigger by 3 inches. Right? Hopefully that helps. Yeah, how are you guys feeling? I know there's one page to go through. Do you want to do the page and then take a break, or do you want to take a break and then go through the page? Or does anybody just want to tell me what you got for question 14?
64.
Close. I got 65 hours. Did anybody else get 64 or 65? Or something completely different? So number 14 actually turned out to be another one of those bed mass type of ones. Right? So it says, on a construction project, 2 carpenters worked 12 3/4 hours each. 3 apprentices worked 8.5 hours each, and 1 foreman worked 14 hours. in total, how many hours did the job take? So essentially this one's would be set up as there's 2 workers times 12 3/4 hours, right? I'm gonna put that in a little bracket. That's one set of folks, right? Plus I need to think about these guys. So 3 guys, each worked 8.5 hours, plus a foreman who worked, well, I guess I don't have to put it in because it's just one dude. Foreman worked 14 hours. Okay. So these would be treated as one. This would be treated, and then all of these together, right? So again, this one here, we would have put that over the 1. This would be changed into the improper. Same thing over here. Change that into the improper, right? Essentially, this will end up being, is it?
40.
Yeah, I'll just go right. Are you guys getting this so far, or?
Yeah.
Yeah.
Okay, I'll do that real quick then. I did have it already. Yeah. 51 over the 4, right? Plus this one that I would have my 3 times my 17 over 2 plus the 14, right? So this one ends up being, what is it, 102?
52.
Oops. Ooh.
Wait.
Sorry, I did something stupid in there.
Okay.
Whoa. I was going to screw myself over there.
51 over 2
Plus our 14 over 1, right? We have to make these all the same. 4 happens to be the one that works. Right? 102 over 4 plus is it again 102 over 4 plus, oh yeah, shit, no, sorry, that was our whole. My bad. That should have just stayed like that. My bad. Did you guys catch that? The mistake I just made there? I quickly swapped it out. All right. 102. So 14 was my whole. And I got 204 over 4, which turns into, remember that's an improper, right? And it goes in evenly, doesn't it?
51.
Mm-hmm.
I have 65.
Yep.
Maybe I'm wrong.
No, you're right. Because, yeah, this was the, this turns into the improper, or fifth, yeah.
Instead of going into such a big number,
Mm-hmm.
right on the second line, you can factor it out, like 2 and the bottom 4
Mm-hmm.
on the second line. Go up to the second line.
Oh.
Go up. Yeah, up. Yeah.
Up to this one.
Yeah, right there. On your pens. Next one. The first. Yeah, right there.
Yeah.
You factor 2 and 4, so you're left with 51 over 2.
You can factor those 2 out?
Yeah.
51 over...
No. You multiply. Before you multiply, you just factor it out, right? 2, and then 4. You're left with 2. So your answer left with 51 over 2.
Yeah. So essentially, yeah, you end up down with that 51 over 2 there.
So instead of going through the big number, you're left with 51 over 2 plus 51 over 2 plus 14.
Look at you. I see what you're saying. Does anybody else understand that, or do you need the bigger number?
I went about it a different way, but when you're finished, I'll be happy to share.
Mm-hmm. So 204. So essentially 14 plus the 51. Sorry, I ended up doing it this way, the 204 divided by the 4, right, which is the 51, and it gets you with that 65 hours. How did you do it, Gary?
I went 2 times 12.75.
Oh, okay, no, no. Yeah, I get what you're doing, and I would have done it that, but this one, and it says it right up at the top, no decimals.
Okay.
Yes, that is the easiest way, and that's how I would do it if I had to really do this on a job. Yeah, I would never calculate hours this way. I would have decimaled everything. Yes. You are not wrong.
Construction master all the way.
Right? Right there. No decimals. Right?
Yes, I see that.
Yes.
Yeah.
It is the easier
You
way.
know how many times I get tricked because I don't looked at the
Instructions.
Whose instructions?
Yes.
That's mark deducted 2 marks off.
Yes.
Instead of passing, it's got failing mark.
Yeah. Yes. And they do that on purpose, because can you follow the instructions? One of the things that used to be told to us was, if a client asks for a deck a certain size, if you're not following the instruction and you make it a different size, they're not going to say, oh, well, okay, no, I asked for it like this.
Yeah.
Right?
We either have to do it all over again or free.
Yes, yeah. Right? So the last one here, we can go over it long, or does anybody want to tell me what they might have gotten as an answer? So what is the new thickness of the wall? So they're saying an overall thickness of an exterior wall is 7.5 inches, consisting of 7/8 inch wood siding, 5/8 sheathing, 5.5 stud, 1/2 inch drywall. Oh my. To increase...
Yeah, these I'm not there yet. I haven't worked with any of this, so I'm lost.
Okay. So the numbers that we'd be pulling out here, so the overall thickness is this. The wood siding, this, and this. To increase the insulation value of the wall, the sheeting and wood siding are removed. Okay. New 7/8 insulation sheathing is installed. 3/4 inch strapping is attached for an... Oh my God. This one... See, this is one of the ones that I would probably end up drawing.
Oh. Yeah, this... I'm working in insulation, but I don't do the math. I just go ahead and follow the journeymans, and they're just taping it and putting the insulation, but I don't have to do calculations. So I would be lost.
Yeah.
But it would be helpful knowing what I'm doing.
Yeah. Yeah, so this one, and this is just the way my brain works. I'm a visual, and yeah, I tend to draw a lot of things out. But if you guys are okay, because I'm actually dying, I got to go to the bathroom.
Okay. Yeah,
Do you mind if we take like a 20-minute break?
Sure.
Yeah, no problem. Yeah.
Okay, cool. I'm going to pause our recording. There we go. Okay, thank you, sir. Okay, so as I was saying, so the overall thickness of the exterior wall is 7.5 inches, and it says it consists of the 7/8 for the siding, 5/8 for the sheathing, right, or the plywoods, 5.5 inch studding, and 1/2 inch drywall. They want to increase the insulation value of the wall, so they're going to put more insulation inside here, right? And then extend out a wee bit. So the sheathing and the wood siding are removed. So they take off the wood siding and the sheathing. So essentially what I did on my side, I actually just crossed this guy out for a moment, and I crossed this guy out for a moment. right? To increase the value of the wall, the sheathing is removed. There you go. New 7/8 insulation sheathing is installed, right? I know it seems redundant that I crossed it out because this is coming back in, but just for my own visual for now, that's what I did. But new 7/8 is going in. New 7/8 is going in. They're also putting in 3/4 inch strapping. The 3/4 inch strapping actually is going to go on the outside and then to be resided, right? So I have to add in 3/4, right? They're going to reattach more 7/8 siding. So I'm just going to put that 7/8 back in there. I'm going to add in the 3/4 inch strapping. Plus, again, the studs. That's still part of it. Right? And the 1/2 inch drywall. And again, I know normally I would have thrown this into decimals. It would have been faster, right? But we're dealing with fractions. I'm going to show you the other stuff later. Right? Are you guys following this so far?
Yes.
Right? I mean,
So good.
okay, good. Yeah. So, and are you guys okay? Again, this was just how I deal with it so I can get a visual of what they're asking. Right? So now essentially I need to find out what the new thickness of the wall is. Right? So again, we have to put these all into apples, right? And it's going to be this one, and this one we have to change. 7/8 plus 7/8, right? We're going to times that one by 2 and these ones by 4. Right? So 6/8 plus 5 and 4/8 plus 4/8. Right? Now we can add all this stuff up. Right? Remember, this one is the whole. It's by itself. If you want, you can throw it over here for a second and then just deal with all the fractions. So 7 plus 7 plus 6 plus 4 plus 4. And we end up with, I believe it's 28/8. But again, remember, that's that improper, right? So 8 goes into 28. 3 whole times, right? And 8 times 3.
8.5.
Yeah, yes, yeah, it's going to eventually be 8.5. You got it. Right? But to play this out, 8 times 3 is 24. So 28 minus that 24. And we get the, whoops. 4/8, which comes down to what? 3 1/2. But we also have to play with this guy again, that other whole. And that's where we end up with the, sorry, I'm just going to bring the answer down here if everybody's okay with that.
Yeah.
8 wholes and 1/2 is the final inches. Right? This was the long way through. Essentially, I mean, you probably could have just added on the 7/8 and the 3/4 to the whole damn thing. Right? But there's our scenic route. Good, and yeah, we're still recording. All right. So that was a bit of a long go. What do we got here? Did someone just send me something? All right. How'd you guys do with that one?
After you did it, it was pretty easy.
Yeah, that's true.
Yeah. But it's those word problems, eh? Trying to find the information that
It's
it's...
a word problem that it's hard to interpret into a math.
But yeah, again, we've got this recorded, and thank you, Poku, for reminding me, right? All of this is going to be available for you guys. All right. Okay. So I'm going to stop this recording and then start a new one for the new stuff.